So let's talk a little more about these parameters that we've seen in the file, in the Fun file, and we also mentioned already in the previous videos. So, well, we know about the threshold issues for doing some calculations. This is the number of elements that we want to include in the ensemble. If our time series are short, we probably want to keep this short as well, because the elements that will be included are the closest one to our scenario, or target scenario. And if we don't have many, well, this would probably result distort the results. This is the value that is used in the IDW. You know that it's to the distance, the inverse of the distance is actually elevated to a power, and by default we put 2, but this is something we will want to play with depending on how our model behaves. We already explained what the gap is. It's the number of days around a day when we're doing the performance analysis that we want to ignore, so to make sure that we're not, let's say, forecasting the present, right? So we are sure that all the data surrounding that day is not used for that prediction. And then the 3 had to do with extrapolation process. This one is how much we're going to multiply the independent variables. So in this case, we will have, for instance, let's say that we have one scenario that is 2020, 2020, then we will have another one that is 40, 40, 40, 40. So it creates a new scenario, and it will. This is the number of scenarios that it will create. So this is the step, and this is the number of steps. If we put 2 here, we have this 20, 20, 20, 20, then we will create a fake one that is 40, 40, 40, 40, and another one that will be 60, 60, 60, 60, and so on. So with these 2, we define this kind of fake extrapolated scenarios. But not necessarily there will be a linearity between the independent variables and the dependent variables. For instance, double the precipitation not necessarily will double the inflow. So here we have this extrapolation power that actually is applied to the independent variable. So let's say that this 2020 precipitation has an inflow of 10 cubic meters per second. Then the 40, 40, 40, 40, instead of being 20, double the value, it will be that value at the power of 2. Right? So this expresses the non-linearity between the effects and the result. And this leads us to this other module here that deals with the variables. So in all these models, there's a direct relationship between the independent and the dependent variable. For instance, more precipitation would result in more inflow, but we could have some cases in which that would be inverse. So for each of the variables, we have to tell it if it's inverse or direct the relationship. In this case, if we put false to inverse, it's direct. And we can also tell them to ignore the relationship if we really don't know after. So how can we know that? Well, if we look at this graph here, at the correlation with the dependent, well, if this is a direct correlation, we will see it in this direction. It will be positive. And if we see it negative, we'll go in this direction. And if we can't really see anything, well, we could probably put known, because we really don't know. Another thing that we have to tell for fullness for each of the variables is if it's a volumetric variable or not. What this means is that if you, for instance, let's say that we have a flow of 10 cubic meters per second today, 20 cubic meters per second tomorrow. If I aggregate both, that would I need to average them, because the flow is not volumetric, right? It's a flux. So I will put in that case 15 cubic meters per second. But if it's precipitation and I had 10 millimeters today and 20 millimeters tomorrow, if I aggregate them, I have to put 30 because I have to add both precipitations to make sense. And since internally FUNES is dealing with discontinuous time series and could have different time steps and everything, that's a value that we need to provide that information to the model. So in this case, the time series are regular, so it's not dealing with anything, so we didn't set this, but it's something that we should. And then in this module, we can see some statistics about the time series, the number of records, and number of node data, the time step, the number when it starts, when it finishes, and so on. And we can also see or create a plot of the time series so we can explore it. Okay, so well, with all these tools we can calibrate our model, and I will show in the next video how better can a model become when we actually calibrate it thoroughly.